In this video, we want to find a limit as n approaches infinity of this rational function. The goal here is to decrease the degree of the terms. So what we have here basically is the square root of n to the 7th, square root of n to the 8th, and n to the 4th. The highest degree is going to be n to the 4th, which is the same thing as the square root of n to the 8th. So we're going to multiply everything by 1 over n to the 4th to get rid of the highest degree. And this is equivalent to just dividing every single term by n to the 4th. Now, when n to the 4th comes inside the square root, it's going to be n to the 8th. So for the numerator, we're going to have whatever's inside divided by n to the 8th. And the denominator is just going to be over n to the 4th. Now I can break this up. So 7n to the 7th over n to the 8th is 7 over n. And then we have 1 plus 1 over n to the 8th. And then for the second square root, we have 8 plus 1 over n to the 8th, all over 4 plus 1 over n to the 4th. Now we're going to take the limit as n approaches infinity. We see that 1 over n to the 8th will go to 0. 7 over n also goes to 0. And then 1 over n to the 4th also goes to 0. So what we're left with is the square root of 8 over 4, which I can rewrite as the square root of 4 times 2 over 4. Square root of 4 is just 2. So this is 2 root 2 over 4, which simplifies to the square root of 2 over 2. And that is my limit.